In this video, I'm going to discuss on the regression methods. Regression analysis are basic idea of regression. Uh, in we know that the correlation informs us about direction and strongness of relationship between two continuous variables under certain assumptions, but it fails in quantifying the relationship. Means the correlation is unable to tell us what is the quantity of relationship. How it tells they are strongly associated with a straight line. A strong linear relationship is there, but how much is the relationship? It fails to tell us. In other words, by correlation, we cannot know how much change in value of one variable, generally called dependent, occurs by the certain amount of change in value of other variable or variable set of variables, which are called independent. So here we suppose that value of a variable in regression analysis, we suppose that the value of a variable is due to combined effect of so many known variables. So I will discuss these things further. In regression analysis, the variable which is supposed to affect is called independent, and affected variable is called dependent variable in general. So as correlation provides direction and strength of linear relationship, the regression point provides us quantification of a relation along with direction. So if we want to quantify the relationship, we need to know the regression analysis. We use different type of words for dependent and independent variable in regression analysis. Generally, the variable which is being supposed to be affected by different variables are called dependent, and the variables who affect are called independent. But in literature, you will find dependent by different names like explained variable, regression variable, predictant, endogenous variable, target variable, control variable, response variable, and for independent, their counterparts are explanatory variable. If you are dependent is regression, then people say independent as regression, like this. So you will find different words for dependent and independent in different branches of study. Whole analysis is based on some functional form. So let us understand what is function. Suppose we have a variable x. It may be age, it may be height, it may be BMI, it may be weight. Now, if we take square root of each value of x, or we take logarithm of each value of x, or we reciprocate each value of x, or we multiply something in each value, we multiply something in each value and add something, these are called, by doing this we get new data, new y, new x. So we say that these all are function of x, because we will get the value of all these by the value of x. So we say that all these notations are, all these definitions are function of x. And all these provide some value on the basis of x. So generally we say that the value which I am getting from this is y. So we name these function by another name, that is y. So y is equals to root x. So y is function of x. Y is equals to log x. So y is function of x. So here I have written so many functions of x, And every one time I am saying it y, you can say another variables name also. You can say z, here you can say w, here you can say y1, here you can say y3, like that, to make differences that this y and this y are not equal. But I have taken similar notation. In each case, we say that y is dependent variable and x is independent. So in each equation, there are two variables. Original variable is y and x, and y is being derived from some mathematical property by operating on x. So we are getting the value of y by the help of value of x. So we say that y is depending on x, or y is dependent variable, x is independent variable. Generally, we use so many types of regression models in regression analysis. So I'm going to discuss one by one each one. So if it is written that y is equals to beta naught plus beta 1 x, and x is our variable, then we say that the y is dependent variable, x is independent variable, and in this functional form, one independent variable is there, and the parameters, the two constants, beta 0 and beta 1 called parameter, and this form of relationship is called linear relationship, and one variable is independent, so it is called simple regression. And in this regression, there are two variables. Y is dependent variable, x is independent variable. And independent variable x may be quantitative, may be qualitative. For example, here y may be BMI, that is quantitative, x may be gender, male, female. So it will be simple regression and my independent is qualitative. But y must be quantitative. Another case, y is BMI and x is age in years. In that case, x is quantitative, independent is quantitative, dependent is quantitative. But two variables are there. Here, there is another model. Y is equals to beta naught, beta 1, beta 2, x2 plus beta 3, x3. So here there are x1, x2, x3, three variables which are supposed that they are affecting y linearly. Now, the number of independent variables in this model are more than one. Hence, this model is called multiple regression. And since if you put x1, x2, x3 value of any particular data point, then it will be in form of beta 0, beta 1, beta 2 plus beta 3. Beta 0 plus beta 1 plus beta 2 plus beta 3 with certain number multiplied by them. And then since parameters are in linear form, say it is called linear regression. Similarly here there is one independent variable x, but we are using different powers of x. It is called polynomial regression, and it is also called linear. There is some confusion among people that it is not linear. Actually, when we talk about regression, linearity of regression models, we see the parameters of the model. We see that if we put the value of x, then how parameters look like. So if we put the value of x, then these x square, x cube will be numbers, will be changed by numbers, and my relationship will be beta 0 plus some number into beta 1 plus some number into beta 2 plus some number into beta 3. And all my parameters are in linear form. So why it is called a linear relationship. Here again, this x, generally we put this x as quantitative in polynomial regression. It is another form of a regression analysis between one independent and one dependent. But in this case, if we put the value of x as 4, then it is not in linear form, beta 0 e to the power 4 beta 1. So it will not be like beta 0 plus 2 beta 1 like that. So this is called non-linear regression, and it has one independent, it may be quantitative, qualitative, but in all cases, dependent variables are quantitative and it must be continuous. But there is single variable. There may be more than one variable also, but I am discussing a single dependent variable. In regression study, we analyze dependent variable only. We treat independent variable as known, as fixed. So what analysis, which variable is analyzed in regression analysis? Dependent variable is analyzed in regression analysis. Whatever inferences we draw the inferences about dependent variable. And since the number of dependent variable is 1 in every model, hence all these analyses are called univariate analysis. All these regression analysis mentioned here all univariate analysis, not the multivariate analysis. So these type of regressions are univariate analysis. If you want to do multivariate analysis in regression analysis, then you have to keep more than one dependent variable in the model. And in that case, your analysis will be multivariate. Generally, people have some confusion on. Now the question is, out of those models, which model I select, and out of my study variables, which variables should I take dependent and independent? So how to select the model? There is no hard and fast rule. The choice of model depends on the reasoning and assumption made by us. However, the location of points on a scatter diagram helps in identifying the type of equation to be fitted. So we draw the scatter diagram, we see the pattern of points in the scatter diagram, and on the basis of that, we decide which models we should select, whether we select the simple regression model or linear model or non-linear model. If the points are more or less on a straight line, then linear equation is assumed, otherwise non-linear equation is assumed. In case of multiple independent variable, suppose we are having one dependent and more than one independent variable, then separate scattered plot of each independent variable is made with dependent variable to know that whether all independent variable are linearly related with dependent or not. If it is so, then we can go for multiple regression analysis. When we draw a scatter diagram, it is hierarchy or it is a practice that we put the dependent variable on y-axis and independent variable on x-axis. Now, the choice of dependent and independent, how we decide? I have 4 or 5 variables and I want to do regression analysis, then which variable should I take dependent and which should I take independent? So again, there is no hard and fast rule for this. Another decision problem in the regression. Okay, so again, it depends on logic which we put, and for our analysis, y depends on x or x depends on y, we decide with our certain reasoning by doing some reasoning. For example, suppose x is a data set or variable which denotes marks of students in statistics subject, and y is another variable which denotes marks of those students in mathematics subject. Now, if you want to predict y based on x, then you can take y dependent, x independent. Vice versa, you can say x depends on y means marks of statistics depends on marks of mathematics. So you can take both simultaneously as one by one as dependent or independent. When we take y as dependent, x as independent, then and we want to make regression analysis, simple regression analysis, it is called y on x regression. If we take x dependent, y independent, we say x on y regression. And generally, its purpose is to make predictions. Now suppose x is hemoglobin value and y is nutritional intake. Now here, y on x is not so justified because nutritional intake changes the HB values, though we can obtain x on y. Means hemoglobin values depend on nutritional intake. But if you think vice versa, then it will not be more logical. Hence, how should we select dependent and independent? It's the researcher who decides by the reasoning or theory or literature review that which is better to choose dependent and independent. Now, can we invert variables in regression model? Means if I have made y is equals to beta 0 plus beta 1x. Now, if I solve this equation for x by transforming the left hand side to right hand side, then whether it is having same meaning of x on y and x on y, y on x. So no, we cannot invert, we cannot transfer left hand side to right hand side to calculate or to show the dependency of other variable on dependent variable. So conceptual framework, what is the how it works? So suppose I'm taking example of some real life problems or daily use variables. It may not be the field of biological field, but you can choose your own problem similar to this one. So concept. Suppose I have asked the income from certain individuals. Someone told 200, 400, 200, 0 like that. Now, suppose I want to predict expenditure of these people. What is expenditure of this person? What is expenditure of this person and this person? I'm not asking from these people. I take a general perception of people, and people told that generally, whatever the public people get the income, the 70% of the income they invest. It means the expenditure of this person is 200 into 0.7. So that will be expenditure. But they also added that if a person's income is 0, x is 0, then the expenditure is 10 rupees. So I defined a formula that expenditure y of any person is equals to 10 plus 0.7 into income. Okay, now by this formula, let us calculate expenditure of each individuals. So the expenditure of first person is 150, second person is 290, third person is 150, like that. And let us make a scatter diagram of the expenditure and income. Okay, so here is the scatter diagram. But what we are seeing? We are seeing that 1, 2, 3, 4, 5, only 5 points are in our scatter diagram. Though we are having so many pairs, 1, 2, 3, 4, like 12 pairs, I think. So there should be 12 lines. So where are other lines? So the problem is that when we are using this model, 10 plus 7x deterministic model. So the people which is having 200 income expenditure is 150. And every people who have income 200, the same expenditure it is by calculated by our model. But in real life, the expenditure pattern may be different. Okay. So due to our deterministic assumption, person with same income predicted as same expenditure, while in reality, pattern may be different. Now, let us start this question differently. Now, let us assume that that is the sum of our deterministic model and y. Y means expenditure. Expenditure is sum, means total of two things, our deterministic model and some random behavior of the person in purchasing. In other words, the expenditure y is equals to this one, which was considered earlier, plus some random expenditure. Okay, so it is called y is equals to deterministic plus random, means my dependent variable is a known variable plus unknown causes. Okay, generally what we do, we suppose that this random part is now having normal behavior with in such a way that its behavior, up and down behavior, sums to be zero with the certain standard deviation. So here I suppose that standard deviation is 20. Okay, generally written as normal 0, 400. So I'm not going to much depth in this one. I'm just want to show you how these things work. So it was my problem. This was income. This was my deterministic way of knowing expenditure. Now I computed, or I recall, or I called random compound behavior. How this was called, how these numbers were obtained, they were obtained from normal distribution, normal probability distribution, in such a way that the mean of the distribution is 0 and standard deviation is 20. So by the computer, I generated this data. So what will be the expenditure of this first person now? It will be sum of this 150 plus this random part. Okay, so why? Now this was the original data, it was the known income, and this is now expenditure, expected expenditure. Expected expenditure, why? Because here the what people were saying and what was the random behavior, both are taken into consideration. Now if we draw a scatter diagram of these x and y dependent expenditure and x independent, then let us see how the scatter diagram looks like. Now the same scatter diagram is now like this one, and we are seeing that our all data points are visible now. Okay, so how we work simple in regression? So we want to predict we want to model a dependent variable y. How we model? We take two part. One part as known part, data part, and another part is random part. Okay. Now this random part and data part are like this. Uh, we collect data in what we do in real life. In real life, we do not calculate this value. We do not calculate or do not generate this value from probability distribution. Generally, we calculate or we collect data of y and x both. What I was saying, I was having x data of x and I was generating data of y by guessing E. In real life, what we do, we collect data of dependent and independent both, and then we choose this relationship beta 0 and beta 1 in such a way that this residual part, random part's role is minimum. Okay, so in real life, what we do, we get two pairs of variable. One is called dependent, another is called independent, and from those data points, we calculate beta 0 and beta 1 by certain rule. Okay, and what is the rule? Suppose I have this data X and Y, income and expenditure. My data points are here. Now we try to draw a line among the points. So here we want to know that what is slope of this line and where this line is going to cut. This is called intercept and slope. Okay, so we want to get the intercept and slope of this line, which is called beta 1 and beta 0. How to get this beta 1 and beta 0, which beta 0 is written as A, beta 1 is written as B. To get these points, these values A and B, we use the data points. Here, suppose this is my own point Y. Y is original Y. This is the original data point. My Y value is this much. If I suppose this is the regression line which represents the closeness of my data, then my line will say the value of Y this much. Okay, so this is called, this much is called, this distance is called a residual. So we choose A and B in such a way that this distance is minimized, means our line goes to the minimum distance of the points, and it is obtained by certain mathematical rule which is called least square method. So least square method is used to get the value of beta 0 and beta 1. So I'm not going to tell what is B square, how least square works, but if you want to know the value of beta 0 and beta 1, you have to calculate some, we have to do some calculations from your data set. Like you have to calculate covariance of XY, you have to know the variance of X, variance of Y, and this formula can be used to get the beta 0 and beta 1 value. So suppose this is my data X, this was my data Y, and I was interested in regression equation Y for dependent, X independent. So I calculated these things. Here deviation is square. Why I did it? I calculated it to get the variance of X, sigma square X, 393. Here sigma square Y, 195. And then covariance, the multiplication of these two, and its mean 229.58. Now, variance of X is 393, variance of Y is 195 rupees square. Standard deviation of X is 19.82. After calculation, you will get covariance is 229.51. Now, beta 1 is covariance of XY upon variance of X. So if I divide 229.58 by square of 19.82 or 393, I will get 0.58. This is called beta 1. And beta 0 is, again, it is calculated by previous formula, and it comes to be this one. Now this is called regression equation of Y based on X, means it will provide us value of Y if we put any value of X. Okay, now these numbers, these 9.13, this 0.58 have some meaning. What's the meaning they infer? Y is expenditure in 1,000 rupees. X is income in 1,000 rupees. Now, What is this 0.58 says? It says that if you increase x by 1 unit, if you increase x by 1 unit, there will be increase in y by this much unit. Means if you are increasing income of a person, if income of a person increased by 1000, then expenditure of that person will increase by 580 rupees. Why it will increase? Because the coefficient has plus sign. Generally, the explanation of this intercept is not always available, but in this example, you can say that if a person has income 0, no income, so here it will be 0, so this term will be 0, then the expenditure of that person is expected to be rupees 9.13. So this is the message of this regression line or this regression equation. Now we want to know that whether what the regression model we have prepared, it is fit or not. Means it is better to predict my income expenditure for income of any person. So we check the model fit, and in model fit what we do. Okay, so this was my x, this was my y original data set. Now we suppose that, okay, let us take income of this person. The expenditure of this person was rupees 14,000 and income was 15,000. Let us put the income in this model at the place of x is equals to, write the x is equals to 15 and solve. See what happens. It comes to be 17.89. However, the actual income or expenditure was rupees 14. So this is residual, means this is random variation. We were expecting 14, but the model is saying 17.89. So these are called predicted. If my model is 100% accurate in predicting y, then here it will come 14, here it should be 20, here it should be 22. It means my model is not 100% accurate. Then the question arises, how accurate is my model? Okay, so to know this, we calculate certain things from this data set. We calculate predicted expenditure. This was original expenditure. Then we see that how much error this model is making, how much gap between true and predicted is there. So we subtract this value from this value and it is called residual. Okay, now we calculate, and it is called random part also of the prediction. So in my prediction, the random part is this one. If you sum this random part, its sum will be 0. Mean will be 0. Okay, now we see that we see that the original income expenditure was having mean 36. The predicted is also having mean 36. Now we want to know how much was the variability in this data. How much was the variability in this data? To know it, we calculate variance of this data or sum of the square of this data. And then we say that out of the whatever is the sum of the square of my data, original data, how much of that is in predicted and how much of that is in residual. Okay, on the basis of this, we make ANOVA table. So this was my original original expenditure data. Its mean was 432. So I calculated y minus y bar square and then sum. So this number 2340 is called total sum of square of a dependent variable y. And since This were YP. This was predicted value. And it also has mean same as this one. So again, we calculated sum of square of predicted values and it came to be 160942. This was the total sum of square. My regression model is showing this much sum of square and the residual model is showing the sum of square this much. If you add these two, you will get this one. And it is written in a tabular form that is called analysis of variance. So we write the sum of source of variation means the how my dependent variable values were varying. What were the region? So one region was my independent variable. Due to income, expenditure was varying. So it was taken in regression analysis, hence it is called regression. Source of variation is regression, means YP predicted. And another source of variation is random. So it is called residual. And total means dependent variable, the sum of square of dependent variable Y. So here 2340 is the same sum of square. If you see these three values and you go in the previous slide, this is total sum of square, this is the regression sum of square, and this is residual sum of square. So it is written like this. Now we write degree of freedom. Degree of how we write degree of freedom. So the regression degree of freedom is written as how many parameters were in your model. So my model was simple regression. Two parameters were beta 0 and beta 1. Hence, the degree of freedom is number of parameters minus 1. So it is 1. The total degree of freedom is how many observations were there. So we are having 12 pairs. So the total sum degree of freedom is 11. And the residual degree of freedom is 11 minus 1, 10. Now we calculate mean sum of square. Mean sum of square is calculated by sum of square divided by corresponding degree of freedom. So there will be no change in the mean sum of square of regression. But here it will be divided by 10, so it will be 73.058. Now after this we calculate AF value, and F value is calculated by dividing the mean sum of square of regression by mean sum of square of residual. And if this value is very large, we say that the regression is significant. Okay, and we calculate p value for this one, and this one is 0.001. Now again we calculate model fit, that is called R square, and it is calculated as you divide this sum of square by this sum of square. Means out of the total variation of dependent variable, what portion was captured by my regression, and it is 69%. So we say that the 69% of the variation of the dependent variable Y means expenditure. The 69% of the variation in the expenditure was due to income. Income के बढ़ने घटने से 69% variation in expenditure was observed, and remaining are due to other causes. A positive association was found between income and expenditure. Regression coefficient of X informs that an unit amount of 1000 of increase in income brings increase in expenditure by 58.58 unit or 580 rupees. The R square informs that out of the total variation in the expenditure, 69% variation is being explained by income. The estimate of error variance is 73.6. our standard deviation is 8.5, our standard error of estimate is 8.5. It is written like that when we represent regression analysis in meaningful form. Further, we check the significance of regression coefficient by t-test. If my regression is significant, then we say that see that whether my regression coefficients are significant or not, and then we use t-test. Now I'm going to show you the same process by the help of SPSS, and in that I will also show the idea of multiple correlation. So here I'm closing my PowerPoint and I'm shifting to the SPSS data file.